Show that the point L, M lies on the circle x squared plus y squared equals to a raised to the power of -2 whenever the line Lx plus my equals to 1 touches the circle x squared plus y squared equals to a squared. So let us begin. So here we have a circle and a line both touching each other at a particular point. So here we have a circle centered at C, and this circle, this equation is given to us. It's x squared plus y squared equals to a squared. And this circle is touching the line Lx plus my equals to 1, let's say at point A. Then we need to show that if this is true, then we have another point L, M. This particular point must lie on another circle given by the equation x squared plus y squared equals to a raised to the power of -2. So let us begin. Now we'll start with the given equation of the circle. So here we have x squared plus y squared equals to a squared. Now we can rewrite this equation as x minus 0 whole squared plus y minus 0 whole squared without changing the equation of the circle. But the reason why I'm writing this, because we are going to compare it with the standard form of the circle, which is given by x minus h whole squared plus y minus k whole squared equals to r squared. That in this case, then the coordinate of the center in its standard form is denoted by h comma k, and the radius is going to be denoted by r, which means that our center of the circle, equation circle which is given to us, has the coordinate 0 comma 0. That means it's centered at the origin, and the radius of the circle is equals to a unit. Okay, now we have the coordinates of the center of the circle 0 comma 0. Let's drop a perpendicular from point C to point A, and this is going to be perpendicular on the line which is tangent to the circle at point A. Now here we can easily define the perpendicular distance CA. So the perpendicular distance CA will be defined by, we'll take the absolute value. We'll start with the numerator. In the numerator, we need is the coefficient of x of the line, so which is L, and this will get multiplied to the x coordinate of point C. That will be added to the coefficient of y of the line, so that's m, multiplied to the y coordinate of the center C, so that's 0. And then this can be also expressed as Lx plus my minus 1 equals to 0, and we need the constant of the line, which is -1. This will be divided by the square root of, we need the coefficient of x, which is L. We are going to square it and then add it to the square of the coefficient of y, which is m. So that means we have m squared. Fine. And what is this? This perpendicular distance CA, this is nothing but the radius of the circle. And we have already defined that the radius of the circle is a unit. So that means we can say that this perpendicular is nothing but the distance a. Okay. So we have a equals to absolute value of -1 divided by square root of L squared plus m squared. Let's get rid of the absolute value by squaring both sides. We're going to get a squared equals to 1 divided by L squared plus m squared, which will be simply L squared plus m squared equals to 1 over a squared. So this is nothing but, this is if we compare it with the equation of a circle given by x squared plus y squared, let's say, and this is radius is given by 1 over a squared, then there is a point L comma m lies on this particular circle, which means that it is going to satisfy the equation of the circle. All we have to do is replace the value of x with L and the value of y with m, and that's going to give us exactly this particular expression. In other words, we can say that the point L comma m is going to lie on the circle x squared plus y squared equals to 1 over a squared whenever the line whose equation is given by Lx plus my equals to 1 touches the circle whose equation is given to us x squared plus y squared equals to a squared.